Okay, if this is this will be y, this will be x. Then what is how yx graph? Yx graph of exponential function will be of this one. This will be curve for y equal to e to power of x. Exponentially increasing one. So what is value of e now? Value of e. So if you look at the value of e, already this also, the approximate will write it here. So up to 2127134 up to 10 decimal is a irrational number. So up to 2 decimal places what I'm putting here now. This having a very good significance in mathematics. Like you can call it like a magic number. Any other time I'll discuss in detail, or when we go for calculus, little bit I'll give the idea of this one. Okay, there's about the e that one. So similarly, what about the y equal to e to power of minus x? The curve will be put x equal to 0. So definitely, I think it will start from certain value. So this is y equal to e to power of minus x. The variation, first we should have a how y and x varies. It will vary exponentially. This is called like a exponentially increasing function. This is exponentially decreasing function. And there's the one basic difference what we can put here. Now after this, few more, like we have few more, like y equal to, so like a to power of 1 minus bx. This is also exponentially increasing one. So how the corresponding graph will be? Already we have seen certain ideas in the graphs, plotting of graphs. Once again, I'm just putting it this one. So it will be the curve should be very difficult to I'll do one thing first. There's a one part. Okay, then you'll get this one. So there's the value of e. There's a y, x here. So altogether, the three graphs is what has shown that one. If you see our most of the physics, what we do know, we'll be dealing with this particular, the most of the quantities which are there in the nature, no, they do vary of this kind. So where do you see this exponentially increasing, exponential decreasing, almost in all the topics of physics? And what are the topics of physics? They're related to something the nature. They're related to something to the real nature. So what do this exponential? It will just give us the information regarding how a quantity grows or decays in nature. That particular information is what available. So that particular information is available from this exponential. So what is this exponential function? So shall we say that it reveals the natural growth or decay of quantities around us, how they will vary with the time or with position, all that particular thing. There is something is very, very, you can say it's a magic number, better you can say that one. So therefore, you can see so many things like how the temperature of an object varies with the time, how a body cools with time, exponentially decreasing. The charge on a capacitor, how it varies with time, exponentially increasing. So almost what all we study in physics, no, most of the physical quantities do vary with time, either of this one. Or like this will be radioactive decay, exponential will come into picture. It is something related to the natural phenomena. The natural phenomena we are trying to express using this particular exponential. There's a very, very beautiful part of this exponential, or what is this is called as Euler function or Euler value. So what is the name given for this? It's called as a Euler number, better say like it. So this is what I just understood about this one. Okay, how a thing is like we have to explore even the logarithms, no? So then what about the logarithms graphs? Like how the log x graph will be? That also we have to check it, no? Okay, let's go for the logarithms. So when I go for the logarithm graphs, let me continue here. So let's go for the plotting of logarithm graphs here. So first we'll plot the logarithms of various functions. So e to the power of x, I'll plot it. I need one more line. I'll extend this line further. There's a log x to the base c. And then afterwards, what we have is like, it should also come and intersect at 1. Log x to the base 2, then the last one. Rough plot, this is what the value, this is x, this is y, where y we have plotted for various things. So this is log x to the base 10, and this is log x to the base 2. So what we have plotted the various functions like y is equal to log x to the base c, y equal to log x to the base 2, y equal to log x to the base 10. First of all, sir, can you tell me what is logarithm? And you have plotted. So you do one thing, just take calculator. Go for natural logarithms. This is the natural logarithms. In the calculator, it will be ln or ln it will be written. There, you just type it x equal to 0. X equals 0 is not defined. So x equals 0 0.1, 0 0.2, it will be negative. X equals 0, we should not define it. It's not defined. X equals 0, 1, 2, 3, 4, 5 like this, or 0 0.1, 0 0.2, 0 0.3, 0 0.4, then 0 till 0, 1. Afterwards, 1, 2, 3, 4, 5, 6, if you keep on plotting, the response will be like this. Then log x to the base 10, then similarly log x to the base 2. So as you take the response will be of this particular thing. Now you can ask like primary question again, sir, what do you mean by logarithm and what do you mean by the exponential? Here we'll just put in a simple way. Logarithms reveals the inputs that caused the growth. What about exponential? Exponents or exponential, right? Exponents. find the final result of the growth. There's a relationship between those two. This is something very important for us. So I think I'm not in a better position to go mathematical treatment. So as we proceed our phase, when we get into our physics now, you can see the lot of the physical phenomena we are going to express using exponential function. In the mathematics, you can treat it like some number and like a sum series, exponent series. In binomial theorem, you're going to say expansion of E. Again, in the exponentials, there you treat E some sort of like some mathematical tool. But in physics, what happens? It will represent the how that physical quantities very naturally. To express that is what the E is brought. Okay, this is about the some basic idea about this one. So let's explore the exponential further. So if we have so first we'll go for exponential rules. So the first rule, e to power of a into e to power of b. So what we are doing is we are converting the product. Here is dot. No? The product is converted into sum. That's all simple. E is called as exponent. The value of E is 2.7 and A will be some power. So e to power of A into e to power of B can be written as e to power of A plus B. So what we have done, we have just converted the product. There's a product, no? And it is converted into sum. By ohm. So what is this exponential first rule? We can convert the product of two quantities into e to power of sum of those two quantities. Like e to power of A is one quantity, e to power of B is one quantity. So this dot is what we are able to product we are able to convert into sum. Next one, e to power of A, e to power of B. This can be written as e to power of A dot e to power of minus B. What happened here? Again, it is, you can see this is the division, no? And to what it is converted. So what is the conversion? The division is converted into the subtraction. Then this will be e to power of A to the power of B. So this will be e to power of AB. The power converted into product. E to power of A all power B is what e to power of AB will write it here. So these are some basic rules what we'll be using this one. So next further, e to power of 1 will be 1. I think any e to power of 1 will anything to the power 1 will be 1. Similarly, e to power of 1 will be 1. E to power of 0 will be 1. E to power of infinity will be infinity. E to power of minus infinity will become 1 by e to power of infinity, 1 by infinity. This will be 0. Widely we'll be using in our physics. Just it's not a rule. Just for a convenient purpose, I just brought it. So at many places we'll be using here. E to power of infinity will be infinity. E to power of minus infinity will be 0. Okay, good. This one. So these are some exponential rules is what we have brought. Okay, now we'll get into the logarithms. So what actually logarithm means? So I have a number 1000. So this 1000 can I write 10 into 10 into 10, or I can write 10 cube. Now using logarithm, what I'll do is I can express this number 1000 like this. Log 1000 to base 10 equal to 3. So what does it mean? That's the same 1000. What does it mean? So what do these three indicates here? What do these three indicate? So if you see again, 10 to power of 3, this is nothing but 1000 equal 10 to power of 3. So if I go for the basic log definition, so this is called like a logarithm. This is called like an index. So what we are doing is this is interconvertible. If a number is like this, x equal to y to power of b, then you can write in the form of logarithm like this. Log x to the base y is equal to this one. This is called like an index form or exponential form. This is called like a logarithm form. I think it's quite clear now. X is just some value, no? X is some value. So I wrote some thing here. This is the fundamental thing. Let me bring that here. Please do all of you look at that sentences once again. When you write x equal to y to power of b, when you write x equal to y to power of b, then what is x? X is output, no? And what is b? B is a base, and y is what? The input. So therefore, logarithm what itself like reveal the inputs that caused the growth. Reveals the input. So there's the input. So it's like a b to power of y equal to x that reveals the inputs that causes the growth. What about exponent? Finds the final result of the growth. So what is the growth? Okay, that's one. As I vary the y, as I increase the value of y, the x will change. The x is the growth, no? So what is the input? Input is y. Okay, and what is x? Like y is the input, x is the growth. So reveals the inputs that cause the growth. Growth is what? X here. So here we will put it here now. X is a growth and y is the input. I think that's what this definition I'm putting now. Finds the final result of the growth. That's what the exponent. What about the logarithm? Reveals the input that cause the growth. So if you take log of growth to the base b, you'll get the input. You'll get the input. And what about exponent? This is the input, this is the output. So it will give the final result of the growth. I think, okay, the sentences which I have put it's do applicable here. So now let's come back here. So what does it mean? This 1000 I can express in terms of this one. So what it says like a, in this 1000, in this digit 1000, the 10 is repeated 3 times. The multiples of 10 is repeated 3 times. In this particular 1000, the multiples of 10, the factor 10 is repeated 3 times. Like this, what happened? We are able to express this particular thing. Okay, now after this, okay, sir, why to express this, why we have to study? Suppose let me ask a primary question like 7891 into 4352. I'm asking you to multiply these two. So, okay, sir, I'll take calculator, multiply it. How calculator does? We don't have any thing which is multiplication. So what calculator has to convert this into addition form. So when you provide this operation, so what calculator does? First, it will find out log of 7891 plus log of 4352. This will get x, y, and it will produce the output r. So the machines cannot, okay, this is one machine whose output is 7891. This is one machine, output is 4352. I want the like a further output which will be product of these two machines. This is machine one, okay, which is going to feed 7891 as a one quantity. Another machine 4352 is what its quantity. I want the product of these two as the output of the resultant machine. Then the machine, what happen, we don't have machines which can take the, which can perform multiple operations, but we do have machines which can perform addition operation. Then they have superposition principle. So therefore what I do is like I'll take help of logarithms. So like that the machines are constructed. So if you go for industries, no, to perform multiplication, we do first convert log, the output, and that will be added. So nothing but the R what it is the product of these two. Is having a wide industrial applications, logarithms. Of course, we just do study the numericals. So logarithm is having a wide industrial applications here. Able to get this one? Okay, now after this, there's a very simple, I just wanted like how many times the 10 is being multiplied in the 1000 is revealed by is 3 times, no, that particular information is what available by the log here. Even I suppose say like the output of one of the machine is 41890. Then another machine is 6390. I want like the final X should be the division of these two. So I don't have machines which will perform this division operation. So therefore I'll go for logarithm. Log E. And this will become X. So what we have done, we have converted the division into this one. So we don't have machines to perform this division operation. We don't have machines to perform this multiplication operation, but we do have machines which can add two physical quantities or which can subtract physical quantities. So definitely what I should do now, I should convert this quantity into log scale. And that is very easy. We do have machines which will convert a normal value into log scale. There's a linear scale. I'll convert the linear scale to log scale. Then this operation can be performed very easily. So this is the background of the logarithms here. Okay, now the types of logarithms will define.